Guys. All right. So class has technically been called off due to the inclement weather that's headed this way. So what I decided, I can't get too far behind though. So because I gave you last week off that day, I really can't give you this week off. So rather than trying to Zoom tomorrow, I'm making this video. That way, if you don't have power, you'll get power. So you can just watch the video anytime that you want to. So what I'm going to do is I'm going to talk through a few things out of chapters 2 and 3. All right. I need you to take notes. All right. Kind of like I'm talking in class. Luckily you can rewind and stop and rewind and do whatever you need to with the video. Okay. Then I'm going to pull up and talk about a lesson plan for a minute. Okay. And I'm going to show you kind of an example of a real simple lesson plan and kind of the different parts to it. And then when you come into class next week, we're going to kind of dig down a little deeper over some things in chapters 3 and 4 and 5. All right. And then I'm going to pull some lesson plan notebooks out of the cabinets in the classroom so you can see what you're going to end up doing and turning in sometime in November. All right. But I am delaying by a week the date that your first lesson plan is going to be due. Okay. Since we're not meeting in person, I really need to do some things with you in person first. Okay. So your homework you've already supposed to have read chapters 1, 2, and 3 and taken notes. Basically you've got those guiding questions for the midterm. So as you're reading, you need to be typing out or writing out the answers to those questions because any of those questions can be on your midterm. And so as you're filling them in, you need to start memorizing them. Okay, because you can't just bull your way through on your midterm. All right. So if you get behind, it's gonna snowball on you because this class is a lot of reading. Okay, a lot of reading. All right, and retaining what you read and being able to regurgitate it and basically intelligently give it back to me. Okay. So I told you the other day, chapter 2 is mostly about the principles of mathematics education. That flip book that you got on the NCTM website, I'd bookmark that little, link because you're going to keep reading in it. All right, rather than scrolling back to find it under the homework assignments. So you've got 6 principles and you've got 10 standards. We've already listed those. Okay, you should now be able to list those back to me. Okay. So chapter 2 gives little bitty things about each of the 6 principles. Well, I'm going to make you go back and read from the original document. That's what that flip book is. All right. So you've already read equity. So next time we're going to discuss equity for a minute. And homework basically from Tuesday was to go ahead and do curriculum. All right. And so we're going to discuss those a little bit next time. So I'm not going to spend a lot of time right now talking about basically chapter 2 because we're going to do a little more in depth of each of those principles as we go. So it's a short chapter. But I do want to talk about chapter 3 for a minute because chapter 3 is really rich with a lot of material. Now, I'm not going to talk about it all right now. And I'm going to probably in class next week, go over some things I'm not going over today. Okay. But there are a lot of things about learning theories. If you want to be a really good math teacher, there's some things you have to know. First, you have to know mathematics. Yep, you have to know mathematics. Okay. So that's taken care of. All right. Your juniors and seniors, your math professors are outstanding. You know the math. I'm confident that's check. We got that. Okay. Especially you 4. Okay. Second thing you got to know is you got to know your students. Well, you don't really have your students yet, but you're going to learn some things about students in general. Okay. So that's one of the reasons you have to take like psychology classes, sociology classes, those kind of classes when you're an education person, because you've got to know how people learn. All right. And then the third, so those are kind of learning theories. Okay. So that's what chapter 3 is about. All right. And then methodology is exactly how you write a lesson plan, teach a lesson plan, all the things about the methods, the way that you actually teach mathematics to people in particular. So not generally how people learn, it's about how you teach mathematics. That's what methodology is. If you were in English, it'd be how you taught English. Okay, so the methodology is how you get something from your brain and how you know to do it into their brain and they can do it. Okay, so you have to be good at all 3 of those to be a good teacher. So chapter 3 is basically how people learn. Okay. Now they are emphasizing mathematics. All right. So make sure that you notice a lot of these learning theories. Okay. So one of the first ones that it talks about, all right, it talks about behavior therapy, behaviorist theory. All right. That B.F. Skinner's the big name in behaviorist theory. So if you've had Ed Psych, you've learned it. If you haven't had Ed Psych, you probably haven't. So think Pavlov's dog. Okay. Behavior therapy was really popular basically 1930s to 1970s. Okay. And basically what it said is that people learn through a series of rewards and punishments. If they do it right, they get 100. If they do it wrong, they get an F, and F is painful. They don't want to do that. Okay. Kids talking, he goes to timeout. Kids behaving, he gets a treat. Okay. So behaviorist therapy was very important. It basically is terrible, but it treated children sort of like, you can teach your dog to sit for a treat. That's what behaviorist therapy is. Now, theory is. Now, there's some validity to that. People do have to be taught how to act. There are consequences for behaviors. Some kids respond better to positive. Some kids respond better to negative. What you don't want to do is take a kid that responds to positive and just kill them with negatives. Like my son, if you scream at him, he's done. Like there's a second set of eyelids that he's respectful. He's looking at you, but there's like a second set of eyelids that come down. The way to get him to do something is to praise him when he does it well and to not praise him when he doesn't do it well. So you've got to learn which kids respond to positive reinforcement and which ones respond to negative. They respond to both, but you've got to be careful. So that's what behaviors therapy is. Then it talks about Vygotsky's proximal zone of development. All right, we've already talked about that. Okay, below my hand is what they already know and can do mastery-wise on their own. Above my hand is what they cannot do. And you better stay between the two. All right, because you're gonna get classroom management problems, misbehavior if you're on either one. All right, so you got to stay between what they already know and what they're capable of knowing. And you want to kind of you want to be pushing toward the top. Okay, so we've talked about that a little bit and you can read it. All right, communities of practice. Basically, it's what MC math majors do. Y'all are a tight group. You work on things together. You got common goals. Usually starts in 301. So basically, that's what it says, that communities of practice are defined as groups of people who share a common concern, in our case, a common passion for something. And they learn how to do it better when they interact regularly. So y'all get together and have study groups. Y'all get together and work on that patterns worksheet. That's what you want to build in your classroom, or communities. All right, safe spaces where kids depend on each other and interact with each other and help each other, except on a test. Okay. Then it's got multiple intelligences. So it lists the 7 in your book, but remember, part of your homework is you go find those 7 and you write me descriptions of each, because on your midterm, I may say list Howard Gardner's 7 types of intelligences. I may say discuss Howard Gardner's interpersonal intelligence. What does that mean? So you got to know enough to be able to discuss any of them. All right. And they're good. We're going to talk about those more in class next time. All right. If you can find a free test to figure out which one you are, take it and see which one you lead with. I mean, it's not going to be surprising that a lot of you lead with logical, mathematical, but also I score high on interpersonal. Like I like to talk. All right. I like to be around people. So you're going to get more than one. Everybody has more than one, but you tend to lead with 1 or 2. We've already talked about mindset, like a growth mindset. So it's actually about how you think kids, how smart they are. Like there used to be a theory that IQs were fixed, and now we realize that actually IQs, they move around. So there's this fixed mindset and this growth mindset. So a fixed mindset would be, my mama's not good at math, I'm not good at math. It's a DNA situation. That's a fixed mindset. My IQ, I'm average. I'm always going to be average, always been average. Okay. A growth mindset is different. A growth mindset basically says, If I work hard, I can do anything. I can't do that yet. Okay. And you really want to push kids toward that growth mindset because it's really true. IQs do change. A lot of that's based on, we're going to talk about this later, but it's based on your experiences. Like, it's hard to give a kid an IQ test that's not biased. All right, let me tell you what I mean by that. There used to be a problem like the Stanford Binet IQ test that was biased. And what it would do is a lot of times these IQ tests are given to kids that don't read or, read, so they got pictures. So it had a series of 4 pictures, and the person giving the test would say, in which one of the pictures is something missing? And the kid was expected to circle a picture of a comb, like you comb your hair with some teeth missing. Well, that's a biased question. So think about for a second who it's biased against. Like, stop the video and just think about it. All right, you're back. Who do you think that's biased against? It's a socioeconomically biased question. Because if you're a poor child, it may be the only comb you've ever seen in your whole life had teeth missing. So for you, that's the way a comb looks. So once a kid sees a real new comb, it's like, oh, I didn't know. So it's really hard to measure somebody's potential. No matter how hard we try, we're usually measuring their actual. And IQ is supposed to be your potential for learning. So it's that growth mindset. How can you know anybody's potential? You can't. So just be real careful when you're looking at IQ scores and you want to promote that growth mindset. Now, I'm a real big fan of, like we're talking about Howard Gardner's theories of multiple intelligences. Some people hate it, some people like it, some people think it's good, some people think it's terrible. I like it, but again, it's got to be used smartly, and we'll talk about that in class. I love Bruner's, all right, because Bruner's is real and it's simple and it works. It's every day in a class. Bruner basically says that you have 3 stages, all right, of learning. 3 stages is representation. All right, you have inactive, you have iconic, and you have symbolic. Now, here's Gann's take. What he's saying is, when you want to teach something new, you have to start completely concrete and slowly move to completely abstract. So inactive is completely concrete. All right. His symbolic is completely abstract. His iconic in the middle is a mix. So you start inactive, completely concrete. Then you move to a mixture of concrete and abstract. He calls that iconic. Then you move to completely abstract. But chances are you don't even do that in a whole freaking year, much less one lesson. Okay. So let me give you an example. If I'm teaching children to add, like just whole numbers, 3 plus 5, inactive would be if I had Skittles and I want to teach them 3 plus 5 is 8. So I've got 3 Skittles in one set on their desk. There's 3 Skittles in a group. There's 5 Skittles in another set, 5 Skittles in another pile on their desk. And I teach them set model is completely inactive. They literally take physical Skittles and they union those 2 sets. And they count how many are in the union. So it's the cardinal number of sets. The cardinal number of sets that don't intersect. Okay? So they see 3 union plus 3 plus 5, they count and they get 8. That's completely inactive, completely concrete. I do that over and over and over and over. 2 plus 7, 1 plus 6, 3 plus 4. What about 4 plus 3? We would do it for days and days and days. Now, after they get really good at that, then I'm going to move to a mixture of concrete and abstract. So maybe now they've got a number line on their desks. Well, how do they do 3 plus 5 now? Well, they put their finger on 3, and when they're adding, they move to the right. 5 spaces, and where their finger stops is the answer, 8. 3 plus 5 is 8. Well, see, it's still got a concreteness to it because they've got a number line and they're moving their physical finger on this number line. Now, after they got subtraction, they go to the left. And we'll talk about how that model still works with integers, positive and negatives later. All right. But that's a mixture. It's still got some abstractness to it because they can't, they don't have the sets anymore. Now, I would move to a more abstract, but still iconic. You see what I'm saying? Like I'm slowly, that was completely concrete. Now I've got a mixture that's mostly concrete with some abstract. Well, what if now, if they, instead of having the number line on their desk, what if they draw the number line? Well, see, and they still put their finger on 3, moves 5 spaces, now it's 8. But see, they drew the number line. See, that's still iconic, but now it's a little more abstract than concrete. So iconic is a mixture, and you're gradually going to take less of the concrete and more of the abstract. And then one day you're going to end up with just blank. 3 plus 5 equals blank. See, that's completely symbolic. That's completely abstract. So that's what Bruner's talking about. And he uses pattern blocks and base 10 and algebra tiles to talk about that. So when you're doing your lesson plans, that's what I'm looking for if it's something you're teaching for the first time. He talks about those Van Healy levels. Those are just geometry. All right. And we're going to talk about that more, but I need you to notice when you're reading, those levels are sequential. If you're at level 0, which is visualization, which means I just know that thing's name is a rectangle. Just like I know that thing's name is a horse when I'm 2 years old. They can't tell you why it's a horse. That's just its name. Rectangle, that's just its name. Then he's going to talk about, you go up to level 1, which is analysis. Now they can tell you the characteristics. It's got straight sides. It's got 4 sides. It's got angles that are right angles. You see what I'm saying? But they can't yet compare anything. That's the next level on informal deduction. Now they can compare a square and a rectangle. Then basically they go up to level 3, which is formal, which is deduction. That's where high school geometry is. Proofs. Well, see, here's the problem. In most high schools, if you're the high school geometry teacher, you're teaching at level 3. I hate to tell you, those kids are coming in at level 0 or 1. Well, they can't jump to your level. You've got to take them from theirs and to get them all the way up to yours, which is not easy to do. Something you need to really pay attention to is this comparison of traditional and constructivist classrooms. Because in your lesson plans, I need to see way more constructivists than I do traditional. So think sort of like inductive and deductive teaching. So traditional is very deductive. Teacher gives them a rule. They work some examples on the board. The kids follow those examples. They do them. They get the right answer. They got 99 problems on a worksheet. Okay. Kids are in straight desk rows. They don't talk much. Teacher talks all the time. Okay. That's very deductive, traditional teaching. All right. Constructivists think inductive. The kids are constructing things for themselves. Conceptual understanding is huge. See, in traditional, algorithm use is real huge. Now, I'm not saying every lesson is going to be constructivist. It's not. There's going to be a mixture of sometimes it's traditional, sometimes it's constructivist. But I can almost guarantee you on your midterm, I'm going to ask you to compare the two. Here's what a traditional classroom looks like. Here's what contrasts that with constructivists. Usually in traditional, kids are in rows. Constructivists, they tend to be at tables. Traditional, the teacher talks all the time. It's very teacher-centered. Constructivist, kids talk a lot. It's very student-centered. All right. So this is very conceptual understanding. This is very algorithm application. So make sure that you can do that. And we've already talked about like inductive versus deductive teaching. Now, I want to talk about lesson plans for a minute. Okay. I'm going to pull up a couple of examples. Now, what we're going to do is I'm moving the date. I'm going to go back and recheck your syllabus and change the date. In a minute, I'm going to go change the date that your first lesson plan of your lesson plan units due. Now, next week, you're going to be writing your first lesson plan. All right. That's going to be part of your homework. All right. And I'm going to take it. I'm going to destroy it. I'm going to rip it apart. I'm going to give you all this feedback, and you're going to take it back and you're going to redo it, turn it back in. So that's going to be done before you do your lesson plan unit. Okay. So that you get better at lesson plans by writing them. Okay. And I've got notebooks in the cabinet we're going to pull out next week and look at, but I want to kind of get you started thinking about it because you need to be thinking about your topics. All right. So let's see if I can share my screen for a second. All right. Now, let me show you this. All right. This basically is some terms you're going to have to learn how to do. All right. Because you're going to hear these terms. You're going to see these terms on the lesson plan. An objective. An objective is a brief, like simple sentence. Okay. A brief statement that describes what the students will be expected to do or know by the end of the lesson. It has to be measurable. Be specific. Do not use words like understand, learn. So you would never say students can understand what slope is. You would say something like the students can compute the slope when given 2 points on a line. Now, that would be different. A different objective would be the students can compute the slope when given the equation of a line. A different objective would be students can compute the slope when given the graph of a line. See, when it's real specific, and it starts the student will. So it's what you expect that student to not be able to do mathematically when he or she leaves the room at the end of the lesson. Don't put two things in one. Don't say the student can make a table and graph a line. No. Those are two different objectives, because what if they can just make the table, but they can't graph the line? Then you don't know whether they can do the objective or they can't. So students can make a table for a linear equation. Students, separately, the students can graph a line from a table. So you want separate things on an objective, okay? And don't say the students understand, because how are you going to know they understand? So if you're like, well, I want them to know what an objective is, then you would say the student can state the definition of an objective. The students can state the definition of slope. The students can state the Pythagorean theorem. A different objective would be students can use the Pythagorean theorem to find a missing side when given two sides of a right triangle. You see, it's real specific, okay? Procedures are what the teacher's going to do to ensure that that objective is met. So look what it says, procedures. What is the teacher doing to ensure that the students are moving toward mastery of the objective? What's happening in the classroom during the lesson that goes with that objective? So I've got to see definitions. You're not going to just say the teacher will define slope. You're going to tell me the teacher will define slope as rise over run. Or the teacher will define slope as the change in y divided by the change in x. Or the teacher will define slope as y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. I've got to see what your definition is, so I see if I like it. I might not like it. I might say that's a terrible definition. If you're putting kids in groups, you have to tell me how you're putting them in there. The students are putting groups of 4 by location proximity. The students are putting groups of 3 by varied ability levels. The students are putting homogeneous learning styles groups of 5. Like, I've got to know how many in a group and how you decided who's in what group. You know, you got to tell me what questions you're going to ask the students. You got to tell me what manipulatives you're using. I mean, it's everything you're doing in your lesson. Materials. You got to know what you don't want to start the lesson and realize, oh my gosh, I need like 5 pairs of scissors. And you're like wasting your time crawling through your cabinet looking for scissors. Those 5 scissors should be on your desk when the kids walk in. So any worksheets around materials, whiteboard, smartboard, markers, calculators, anything the kids need, physical objects, rulers, laptops, iPads. What do they need for this lesson? All right. Then it's going to ask you assessment. Now, there's two kinds of assessment, formative and summative. Formative assessments, what's happening during the lessons. It's embedded in the lessons. You don't stop and do it. All right. So it's basically to give the teacher feedback to see if the students are on track to master this objective. And it's so the teacher can change what he or she is doing in the middle of the lesson. All right. So notice what it says. Formative assessment procedures are employed by teachers during the learning process in order to modify teaching and learning activities to improve student attainment. The goal is to monitor student learning and to alter your instructions. You ask a kid, what's the slope of line A? And the kid misses it. What you going to do? How do you know they don't know? Because they gave my assessment might be, the teacher will know the accuracies of the student's answers to example 1. So if the kid gets it right, we go in, we track him, we moving on. If the kid gets it wrong, we got to back up. Okay. Now, it won't always be. It may be you're watching their facial expressions. It may be that they've got whiteboards and they're working on that whiteboard and flipping the answers around, and you're going, good, good. Johnny, I think you got a sign problem there. Double check that. All right, Jane, I need you to rethink about that. Let me give you a hint. You see, you're just giving quick feedback, but it's very informal and it's in the middle of the lesson. Formative assessments are to give a grade. They're like the unit test at the end. All right. So summative, let's look at it says summative given at the end of the year or the unit. Formative assessments given throughout the learning process. Okay. So the reason I'm telling you that, let me show you an example of a lesson. Okay, let me stop sharing this one. All right. Now let me share something different with you. Here's a sample lesson on slope. Now, this is the form. This is the way I want you to set your lesson plans up. You're going to tell me what day it is. Now, if it were a real classroom, you'd say like, Wednesday, September 11th, 2024. Okay. But for you, it's going to be like day 1, day 2, day 3. Okay. You're going to tell me what grade this is. 8th grade. What course? Algebra. It may be 9th grade geometry. Well, what if it's 10th grade geometry? Well, see, if it's 9th grade geometry, I'm going to know those are more advanced kids. If it's 10th grade geometry, these are not your advanced kids. So I expect your lesson to be slower. You see what I'm saying? Like, so it matters. Your name's going to be the teacher. You're going to tell me your unit topic. Maybe it's solving systems of equations. Maybe it's informal proofs in geometry. Maybe it's unit circle in trigonometry. Maybe it's probability in 7th grade. You see what I'm saying? Like you got 7th grade up here and you're doing a unit on probability. Simple events. Now we're going to talk about Common Core standards. All right, these are the standards from the Mississippi Department of Education website. And I'm going to put a link in the homework. The mathematical practices are in your book. Those are those in that very first chapter at the end. They've got those 8 mathematical practices. And you're going to tell me where in your lesson you're doing which practice. So this is an example. Now, what I'm doing is, this is an example of a lesson plan where I'm introducing slope. All right, say to a 7th grader. All right, look what it says. Here's my objective. The student will state the definition of slope. Not use it, just state it. So look what this is what the student can do. See, it's very measurable. Either they can correctly state the definition or they cannot correctly state the definition. So I know check mark or no check mark next to John Anderson. Either he can make the objective or he cannot. So look what it says. The teacher will ask the students what they think when they hear the word slope. Then the teacher will show a picture of a mountain, like a ski slope. The teacher will explain the coding of ski slopes due to like trees, terrain, steepness. Blue slope, green slope, black diamond. Okay, you with me? Now, sometimes instead of writing all this out in this little column, I'll say, see teacher notes. Then behind this typed lesson plan, I might have handwritten the definition of slope. all right? I might show a video. That might be the way I introduce slope, is to show a video. I might have like an incline and start rolling a marble down it. Because I want them to know that slope is the measure of the steepness of something. But in math, it's the measure of the steepness of the line. That's my definition of slope. The measure of the steepness of the line. So if you give me that definition, if I don't like it, I'm going to circle and go find a better definition. Okay, because there are a lot of definitions of slope. This is just the one I usually start with. Remember, I'm introducing this. The teacher will then explain that to ensure uniformity, because I don't like snow skiing. I like water skiing, but I like snow skiing. So my husband likes it. So he looks at a mountain and goes, that's not very steep. And I'm looking at it going, that is so steep. So we have to have some uniformity in how steep something is. So for us to all have the same uniformity in determining how steep something is, we've created an algorithm, a formula for it. So it's the change in the y values divided by the change in the x values. The change in the vertical distance divided by the change in the horizontal distance. Okay, now notice, these are the materials I'm going to need for this lesson. I mean, pictures of mountains, whiteboard, and a marker. That's all the material. I don't need scissors. I don't need protractors. I'm not taking them out to the stairs, to go up and down the stairs. You see what I'm saying? Remember what assessment is. How do I know they know? How do I know they can state the definition of a slope? How do I know they're tracking with me? The teacher will note the body language of the students and the accuracy of the answers to questions. John, what's the definition of a slope? Gets it right or gets it wrong? If I'm giving the definition of a slope and I see a kid going, either they're in pain or they don't know what I'm talking about. See, I'm going to back up and rephrase it. So these are the 4 headings you're going to have on your lesson. Now look, I'm still working. Do you see how I just have objective 1? I'm still working on objective 1 down here. So I started with this definition. Now I've moved to this definition. So the teacher will then give the students the points 1, 5, and 3, 8, and ask the students to graph the points on their paper and draw the line passing through those points. Together, the teacher and the students will determine how steep that line is. How do we find the change in y between those 2 points? See, I'm going to let them figure it out. I'm not telling them. See, I didn't put y2 minus y1. I just said change. Now, I might put them in groups to do this. I might put them in pairs to do this. In this particular lesson, I'm just doing the class as a whole. Now, I might stop. It might say in my lesson, this teacher will give the students 3 minutes to pair share. In other words, everybody's going to be assigned a partner and they've got to discuss how they think they're going to do it. Then the teacher will call on a pair to give their opinion. You see what I'm saying? Like, you can be real specific. All right. So these are some of the questions. How do we find the change in y between those 2 points? And I might just ask a particular student. I might ask some other students. I might, throw the question out there and let somebody, whoever wants to answer it. The students, with the teacher's help if necessary, will find that slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. They may not be able to figure that out on their own. That's why it says, with the teacher's help if necessary. So now I've turned this kind of into my definition of slope, how we're going to find slope. All right. The teacher will then give the students these points, and it says, see teacher notes. What does that mean? It means by hand, I've written in the end of this lesson plan, I got teacher notes, because it gets long to type in this column everything you're going to do. And typing math notation gets sticky. So that means that I'm going to get what 3 points. You can't just say your teacher's going to use. I want to know what 3 points you're going to use. So I'm going to flip to your teacher notes and see it all worked out there. Because they can't use all 3 points at the same time. I want to know which 2 points you're going to grab first. I want to know what they're going to do when you hand them 3 points instead of 2 points. You see what I'm saying? So look what this says. The student will be able to calculate the slope of a line when given 2 points on the line. So now I'm going to move into this. Using the definition, and it'd be better to say using this definition of slope, using this formula for slope. So the students will graph the following points and draw the line passing through them and find the slope, and then find the slopes of the lines with the following points. So on their paper, they're going to graph the point 4, 5, -5, -1, 6, and draw a line. Then they're going to find me the slope of that line. But I want to see that worked out on your teacher notes afterwards. See, it says, see teacher notes. Then the kids are going to do again this two different points, another line. The teacher will walk around the room as the students work, assisting when necessary. The teacher will put the students in pairs by proximity to discuss their work and answers. Again, see teacher notes. Because see, I want them to know in a minute that you can call this pair X1, Y1, or you can call that pair X1, Y1, and you get the same answer. That freaks them out. The teacher will then ask the students what they notice about the sign of the slopes and the orientation of the line. See, I want them to discover on their own that when slope is positive, it's rising when you look left to right. When slope is 0, it's a horizontal line. When the slope is negative, that line's dropping. When it's vertical, they get no answer. So see, they're discovering this for themselves. The teacher will then work this. I want them to discover about horizontal lines, about vertical lines. As the pairs discuss and work the examples, the teacher will walk around the room, listening to the discussion, questioning students, and offering assistance as needed. Then the teacher, along with the students, the class, along with the teacher, will discuss the following question. When is slope 0? When is slope undefined? What kind of lines have undefined slope? What types of line has a slope of 0? See teacher notes. Now, this lesson would keep going. I'm not going to keep going. Is everybody with me? But you see what a lesson plan looks like. How am I going to figure out if they can do this? The teacher will note the types of questions asked by the students. The teacher will note the discussion in the pairs. The teacher will note the accuracy of the answers to the examples. It might be at the end of the lesson. It might be down here at the very end. The teacher will give the students an exit card and note the accuracy of the answers on the exit card. So you've got to, you're going to be writing a lesson plan. So what you're going to be doing is you want a more constructivist classroom, a more student-centered classroom, manipulatives. Maybe like one of you, I think it was I think it was Thin that said that one of his articles, the teacher took the students out in the hall to the stairs and learned how to do slope, looking at the stairs up, in the school. You might have grabbed an incline, like I said, with a marble, and they're going to measure. You might take them to the wheelchair ramp. Get them to find the slope of that wheelchair ramp and discuss what if the slope was steeper? Is that a good idea or bad idea for a wheelchair ramp? Less steep, better? You want them to start really understanding what steepness is. So I'm not saying this is a perfect lesson. It's not. I can make it way better. It's use an example of sort of a first lesson. Do you see what I'm saying? I would want some things more particular. I better see the teacher notes. I'd want some different assessment, maybe a little more formal assessment. So this is what you're going to be doing. Okay, let me stop sharing that. Now I'm going to put your homework assignment up. Okay, next week we're going to finish up chapter 3, chapter 4. All right. You're also going to start reading it. You got to get your articles ready. We've got another article's going to be due. So mostly what we're going to do is finish talking about equity, and we're talking about curriculum, those principles out of that flip book. We're going to double check we're good in chapter 3 and chapter 4. You're still going to be reading ahead into chapter 5. We'll pull some lesson plans out of the cabinet and let you see what the notebooks look like. And I'm going to let you, remember, you got to have your order. You got to have kind of your unit topic. Make your own life easier. Pick a unit topic that you can find activities, manipulatives, projects, whatever, because you have to have a more constructivist classroom if you want a really good grade. Okay, so make your own life easier. If you're thinking about a topic, Google activities for systems of equations. Google ways to teach proofs that are not two column proofs. Google probability with and or. Google how to teach fractions to set activities for fractions. Google ways to teach irrational numbers. Do you see what I'm saying? Like activities, manipulatives, technology, software. I mean, make your life easier and pick something that you know you can find those types of things on that topic. Okay? If you need me, email me. I'm happy to meet you in my office, Zoom with you, whatever we need to do. All right. So you've already got Tuesday's homework is up. And in just a minute, I'm going to post Thursday's homework. All right. If you need me, contact me and I will see you next week. Y'all stay safe.